Malaria is an infectious disease that can be fatal. Malaria is spread by humans by infected mosquitoes. Scientists investigated the behaviour of mosquitoes to understand how the spread of malaria could be controlled. So we've got a container full of mosquitoes and some socks. They're infected mosquitoes. They are uninfected mosquitoes. And they basically put them in the pot and they counted the number of times the mosquito landed on the sock. So you've been asked to name the dependent variable and suggest one control variable in this investigation. So the dependent variable is what you measure. So they are measuring the number of times the mosquito landed on the sock. The control variable is the number of mosquitoes. You could add any of these, as long as they are basically things that you can tangibly control or keep the same. That's what control means. Infected mosquitoes landed on the socks 3 times more often than uninfected mosquitoes. Explain how this information can be used to reduce the spread of malaria. So basically, if the mosquito's landing on the sock, it's not going to be landing on a human and biting it. So you could use this method to trap infected mosquitoes, just like a mosquito trap. So where the ticks are, there are 2 marks available. Or you could suggest that people change their socks regularly, 1 mark, to reduce the chance of mosquitoes landing on them. That's another separate mark. So again, you've just got to make up 2. Tobacco mosaic virus affects many species of plant. Figure 5 shows a plant affected by tobacco mosaic virus, or TMV. So they tell you TMV destroys chloroplasts in the leaf. That's a bit of information you've been told. Explain how this could affect the growth of the plant. We're looking to make up 3 marks. So, if there's less chloroplast, there's less chlorophyll. So there must be less light being absorbed by the plant. Yeah, that makes sense, doesn't it? The chlorophyll is the liquid inside the chloroplast that helps the plant to absorb that light. So if there's less of it, there's less light being absorbed. This will reduce photosynthesis, and this means there is less sugar or food made, so therefore there is less growth. So, question 7, tick the right word equation for photosynthesis. So that's the last one there. You've got to really look at these carefully, girls. If you get it wrong again, I've indicated here, really clearly scribble out your answer. Figure 9 shows some of the apparatus that can be used to measure the rate of photosynthesis. The rate of photosynthesis in the pondweed is affected by different colours of light. Describe a method you could use to investigate this. You should include what you would measure, so that's your dependent variable, and any variables you would control. Okay, your control variable. Now, girls, I'm going to advise you to, with these long 6-mark questions, always lay it out in the following way. First of all, establish what they want. Well, they definitely want that. They definitely want that. Okay, but actually, that's not going to be enough really for 6 marks in a method question. So normally what we do is we have sections when we're writing up a method. Section that indicates what you change, your independent variable. A section that indicates what you measure and how you measure it, your dependent variable. So here it's told you you're going to change the colour of the light. But girls, tell them how you're going to do that. I'm going to use a coloured filter on a lamp to alter this. Coloured filter is just a clear bit of transparency. Okay? Easy. Dependent variable. I'm going to count the number of bubbles produced in 1 or 2 minutes. Now you could just collect oxygen. Some of you might have said that, and that's absolutely fine. So I've got 2 sections there where I've clearly laid out what I'm going to change, what I'm going to measure. So I've done this part of the question here already. So then I'm on to my control variables. I have a little section there on that. Now with control variables, it's really important you state how you're going to control them. So I'm going to control the temperature of the water. I'm going to use a water bath. I'm going to control the supply of carbon dioxide. I'm going to use 2 scoops of what we call soda lime. You may not have known that, but you only have to put a couple of control variables down. So if you hadn't put that down, it's not the end of the world. I'm also going to control the light intensity, different to the colour. Okay, so each time I'm going to place the lamp 50 centimetres away from my plant. Now they're always going to give you a diagram. So your method is always going to start off as follows. So I've got my little method section. I've done my control variables, tick that off. But I just need to describe now the method that I'm going to use. Okay, so set up the equipment as shown in diagram. You do not have to describe that again. You just need to tell them how you're going to do that. You're going to do exactly what it does in the picture. I'm going to place a lamp with no filter 50 centimetres away from my plant. I'm going to use a ruler to measure this. I'm going to leave it to settle for 2 minutes. That's what acclimatise means. So just basically leave it for 2 minutes. Once you've left it for 2 minutes, I'm going to count the bubbles released in 2 minutes. I'm going to write that down. I'm going to do it 3 times and I'm going to take a mean. Now, normally you get up into the higher bracket of marks by implying that you're going to take repeats. So point number 4 is actually quite common in all method questions. And then look, if I've put numbers down, all I have to do is say, I'm going to repeat step 1 to 4, 1 to 4, and I'm going to use different colour filters, which I've already mentioned at the top, and then I'm able to compare my results. I didn't write a great deal there, you can see, but I've got my sections, okay, and I've got clear numbered parts to my method. Okay, limiting factors graph. The scientists said, light stops being a limiting factor at a light intensity of 20 units. Give evidence from figure 10 to support this. So I'm going to look at my graph. What happens at 20 units? At 20 units, the line levels off. There's no further increase in the rate of photosynthesis. So no matter how much I increase the light intensity, the rate of photosynthesis doesn't go up anymore. Okay, so I've just put down the rate of photosynthesis does not increase beyond 20 units. Or you could just say the line levels off. Okay, what could be limiting the rate of photosynthesis at this time? If it's not light, it could be CO2, it could be temperature. You just need one of those. Okay, amylase. Amylase is an enzyme that digests, breaks down. A student investigated the effect of pH on the activity of amylase. This is the method he used. He mixed the amylase and starch. He put the boiling tube into a water bath, presumably just to control the temperature. He removed a drop of the mixture every 30 seconds and tested for the presence of starch. He repeated the investigation at different pH values. So it started off with starch in it, but he's measuring how long it took for there to be no starch left because it had been broken down. Okay. The student concluded pH 7.25 was the optimum pH for amylase enzyme. This is not a valid conclusion. Suggests 2 reasons why. So let's have a look at his results again. Okay, he's basically saying between here and here is the most effective. Now you could argue that he's right because it took less time, but it could be any value between those 2 values. He didn't test it, okay? He's not done any repeats either. That would make an investigation less valid. Okay, so when you see that someone's guessing it's in between that value, well, they don't know. Okay, they haven't tested it. And also, with no repeats, you don't know that your answers are not just a fluke.